Hey students, in this exercise, we want to calculate the total energy that is absorbed by the bond of both labs at the point of compressive fracture. So they give us the area of the bond, that is 6.4 times 10 to the negative 4 meters square. That will be the same as 6.4 centimeters square. The combined length of the bond, that is 0.79 meters, that means 79 centimeters. The breaking stress of the bond, there is SB, and is equal to 10 to the 8 pascals, and the modulus of June, that is 14 times 10 to the 9 pascal. So the formula to find this total energy absorbed by the bond at the point of compressive fracture for one of the labs is going to be equals to 1 over 2 times the modulus of June uh, times the area of the cross-sectional area of the bond divided by the length of the bond um, multiplied by the variation in length square of the bond. Of course, this variation is due to the force that is acting on the bond, the compressive force. Now, we know that the strain is equal to the variation of length over the initial length. And at the same time, the strain is equal to the breaking stress divided by the modulus of June. So remember the Hooke's law. So now making delta L over L equal to SB over Y, and we solve for delta L, we have the delta L is equal to uh, SB times L over Y. So this would be the expression of delta L if now we get and replace this delta that I have over here by this expression, and we get that the energy absorbed by the bond at the point of compressive fracture would be 1 over 2 modulus of June area of the bond divided by the length times, in this case we multiply by the breaking stress times the length over the modulus of June, and we have to square all this. Why? Because this is the expression of delta L, and it's delta L squared. So we get here now that this energy is 1 over 2 modulus of June times the area over the length times the square of the breaking stress times the square of the length over the square of y. If now we simplify this y over here with this one of the y's that we have in the denominator, and we simplify this L over here with one of the L's that we have in the numerator, we are going to get now here that the energy absorbed by the bond at the point of compressive fracture would be 1 over 2 times the area times the length times the square of the breaking stress, all these divided by the modulus of G. So once we have this formula, we are ready to substitute the numbers and calculate this energy. So now we know that the energy would be 1 over 2 times the area. This area we know that is 6.4 times 10 to the negative 4 meters squared times the length, that is 0.79 meters, times the square of the breaking stress. You know that is going to be 10 to the 8 Pascal. Pascal is the same as Newton over meter square. All this divided by uh, 14 times 10 to the 9 Pascal, that is the same as Newton over meter square. Let me do now a dimensional analysis here very quick. We have the area in meters square. We have the length in meters. We have the square of the breaking stress. So this would be Newton squared over meter squared is meters to the fourth power. All these divided by newtons over meter squared. Let me flip and multiply by this expression so we get meter squared times meter times Newton squared over meter to the fourth power times meter squared over Newton. I will simplify this Newton with this one. I will simplify this meter squared times meter squared is meter to the fourth with this meter to the fourth I have over here. And my output unit is going to be meters times Newton or Newton times meter. Newton times meter is going to be the same as Joule. So we have the correct units. So we are working with the correct units. All the units are current, right? So we don't have any problem here. So what I'm going to do now, I'm going to multiply 1 over 2, that is 0.5, times 6.4 times 0.79, and I will divide that by 14, and that is going to be equal to 0.18. Now we have this 10 to a negative 4, we have this 10 to the 8 squared that becomes 10 to the 16, and we have this 10 to the 9 that when you move it up is 10 to a negative 9. So this is 10 to a negative 4 times 10 to a negative 9 is 10 to a negative 13, and 10 to the negative 13 times 10 to the 16 would be 10 to the third. So this would be 0.18 times 10 to the third power, what? Joules, right? So this is in joules. So we can say that the energy is, when you multiply 0.18 times 10 to the third, 180 joules. So this 180 joules is the energy that is absorbed by one of the labs, right? If now we multiply this times 2, we get 360 joules, and 360 joules is the energy absorbed by both labs. So I hope that you understand, now this type of exercise where we are going to find the energy absorbed by the bond at the point of compressive fracture.